Hi.
Hey. All right.
Virginia is a computer programmer, right?
Say it again.
I think she borders Kentucky and Tennessee.
Oh, I know that Virginia too. Yeah, she's great.
No, I feel like I've met here on. I've met a Virginia on Discord before. Probably a different Virginia.
Might be.
Imagine, what are the odds? All right, I'm just getting this set up right now. Then I already solved the easy one, so share my solution later if anything. All right, so I don't have too much experience with binary search trees, honestly. I've been dabbling a lot with graphs lately, so I'm starting to learn the graph algorithms and how to traverse graphs and all that stuff. And typically that does make you better at binary search trees and just trees in general, because a tree is a limited form of a graph. But let's see what this is all about. Yeah, hopefully we can solve it. All right. So given an array of integers pre-order, which represents the pre-order traversal of a BST, construct a tree and return its root. It is guaranteed that there is always possible to find a binary search tree with the given requirements for the given test cases. A binary search tree is a binary tree where for every node, any descendant of node.left has a value strictly less than node.val, and any descendant of node.right has a value strictly greater than node.val. Okay. And then a pre-order traversal of a binary tree displays the value of the node first, traverses left, then traverses right.
I don't see the stuff that you're reading. I see the construct binary tree pre-order traversal. But
right here, right?
wait a second. Oh, okay. Now I see it. I didn't have your stream open. I was just listening without looking.
Oh, yep.
Basically.
I'm just sharing it right here.
Yeah, this is a good one.
Yeah. So you can see that the input on this one, so we have to return a tree. Okay, okay.
So how do you so I'm using my desktop. How do you do full screen? I mean, it's already pretty much full screen, but how do you do like complete full screen?
What do you mean?
Like
F11, I think.
F11. Okay. But it still has like on the left there's still stuff, and on the bottom there's like stuff too. How do I do like complete full screen?
I don't know if it'll do that.
Oh, okay. That's what I was trying to get. It's big enough, but I was just seeing what else. Yeah, Leetcode. My favorite one is HackerRank, just because Leetcode is like completely white. You know, like on the background, everything is white.
Yeah, yeah.
And
Yeah,
then HackerRank is like
HackerRank too.
black and green, so it's like easier on the eyes.
Yeah,
you can
gotcha.
change the theme.
Oh yeah, okay.
All right, and then we have constraints are going to be, so the array that's passed in, its length is going to be anywhere from 1 to 100. And each element's value is going to be anywhere from 1 to 1,000. All values of pre-order are unique, so there's going to be no nodes, quote unquote nodes, that are equal to any other nodes, which make things a little bit easier. All right.
Just a tad.
Yeah, yeah. Yeah, this is an interesting one.
8, 5. Pre-order traversal. Huh. Yeah, I'm not familiar with terminology so much either.
Yeah, so they're passing in an array, right?
Yeah.
And we have to output a binary tree.
So
This
the
dot
difference between
val.
traversing an array,
What was that?
the difference between traversing an array and looping through an array is traversing gives you more control.
Yep.
Yes, it's like.
So we just have to convert the input into a binary tree, though, essentially, right? Construct binary tree from pre-order traversal.
The pre-order is basically going from left to the right. Right. Going all the way down to the left, and then if there's nothing more on the left, you go to the right.
Yeah, so you're evaluating each element one by one, essentially. So the first element is always going to be the root.
Yep.
Yeah.
Okay. So
There is
we
some pattern, but I am not sure if it is always valid. Look like for every element, if we move 2 elements, we will meet its children. For example, if we are at 8, and if we no, there's some pattern. For example, 8 followed by its children, 5 and 10. Then after 10 we have 5 followed by its children 1 7. After 7, the children of 10.
Can you send the link for that problem?
yeah, posted
Oh,
it
it
in
just
the
was
chat.
2008. Okay, cool.
Yep.
Yeah, this is a good problem.
Yeah, this is a good problem.
Yeah.
So
Like easy
so
to understand,
so
but it's not easy to do.
so basically what we have to do is we take this 8. We can technically just take this 8 before we even loop through the rest of this thing and just create the root of the tree with this, right? And then I'm just throwing a solution out there. Let me know if anyone else has anything else. But then we could loop through this array one at a time. And with each element, we build out the tree. So since this element right here is less than the root node, then we would set this, well, we'd only set,
Smaller means left, bigger means right.
yes, but we'd only set it if this dot left is empty. If this dot left is undefined, then we'd set this dot left to a new tree node with 5 as the value. But if, let's just say there was a 4 that came before the 5, or let's just say we have the 5 already as this dot left for this 8, and then we come across this 1, it's like that would also be this dot left, but since this dot left has a value attached to it already, we would go from this node down to this dot left, and then we would continue going down this dot left or this dot right, if depending on the number, until the this dot left or the this dot right that we're supposed to be adding it to is undefined, right? Or something like that.
Something like that.
So quick question, how do you know which order
Calculation.
started?
I think I heard 2 questions there.
I think there's probably a way to write like a function, like every time you pass like the position right within the tree using the pre-order traversal way, you get the position in the binary way. There's probably like a mathematical function that you pass in, position 3, and then if it's position 3, then use this formula, and then it should be position 5 in the in the binary search tree.
Can you type that out in the code editor? So you could just break it down a little bit more.
Yeah. Not sure if are we using the same exact code editor?
Well, I posted the link, so you could hop into mine if you want.
Oh, okay. So if I cannot edit in read-only editor. I can only look at it. I can't type in it.
Let me see.
I'm a guest. I didn't sign in. I've never used this. This is really cool, like a shared code editor. I've never used this kind of thing.
Guest? Which guest are you?
Yes, it is pretty cool.
All right, I just made you read and write. You should be good.
Okay.
There you
Oh,
go.
nice. So, yeah, I don't know like exactly how to do it, but I think this just goes from yeah, maybe you have a better idea. I was thinking there's got to be like a mathematical formula for like the input, and then for every position, say it's 0. So if it's 0, it's definitely position 0 on the output, right? So if it's 8, whatever is here, it's whatever 0 is 0, right? I'm just thinking there's like got to be like a mapping or function.
Are you talking about like the index of 0?
Yeah, the index. I'm thinking there's got to be like the mathematical formula to calculate. Like if it's position 0, then 0. If it's position 1, then 1. If it's position
Like an
whatever.
iterative function, an index plus plus? Like where you increment? Or are you talking about like a for loop or a while loop?
No, probably you have to use like for or while loop. I have to give it a little bit more thought. But I was just thinking there's got to be like a really simple mathematical formula to get the index, like you said, from the input and give you the index of the output. Yeah. Because 0 is always 0. Like you start at the root, right? So whatever is 0, 0 is 0. We know that mapping. But 1 is probably 1 too, right? If it's 1, then it's 1. But other than that, I really don't know how to.
What do you mean 0 is 0?
Like if
The
the
root is the
index,
root, is what he means.
Okay.
yeah, the root is the root. Yeah.
Yeah. So 0 is going to be the root, sure, but 1 might not necessarily be
1.
the left
Yeah.
or the
1 could
right.
be 2. Yeah.
Because
Right.
No.
because if 5 is 10, then it's going to be root dot right. But if it's 5,
Yes.
then it's going to be root dot left.
Yes.
Yeah.
Oh, okay.
So there's no way to really
Yeah.
know unless you calculate the value of the current node to know whether the next node should go to the left or to the right. So I'll just jot down so basically, and I'm gonna type it out first right here. And we have 8, right? 8 is, we're gonna create a tree node with this, and that's the one we want to return, right? So we could say create node to return, and that could be, we could just call it like root node or something of that nature. And that's this right here. So this is the root node. Then we come across this 5 right here. And we come across this 5 because we're gonna basically loop through this one by one as we encounter them and build out this tree. So once we encounter this 5, so let me just do loop through pre-order array. The thing is, the fact that they gave us the word pre-order makes me think that there is some type of formula that would make this easier, but I'm going brute force for right now. So loop through pre-order. So the first one we catch is 5. So we're going to have this. This is going to be the next node in the binary search tree, right? How do we know where we place that. We know where we place it because if it is less than the
If it's
current node,
less than, yeah.
then we have to, if it's less than the current node and the current node's left is taken, it already has a value in it, then we have to traverse the graph. I mean, traverse the tree. But if it's less than the current node and the current node's left is empty, then we could just set the current node's left as this node. So there's kind of two scenarios. One, what's up?
It wouldn't if it's less than. I mean, assuming that we already know it's the root, and then the next number after the root. If it's less than, then we always know it's on the left, right? If it's less than, then the left wouldn't be taken, right? I don't know. I think if it's on the if it's less than, then it should automatically be on the left, right?
Yeah, yeah. But let's say, for example, then we get to this one right here. After we set this 5, so root dot left equals 5, then we're gonna get to this 1, and so we're like, okay, is this current 1 less than this 8? Yes, but we can't just store
Oh,
the 1 in this dot left, because then we overwrite this node right here, and plus that's the incorrect answer. The 5's already there, so we need to actually traverse down to the 5 node and then check again.
okay.
Is this 1 greater than or less than? If it's greater than, we store it to the right if there's nothing yet in the right. But if it's less than, then we store it on the left if there's not already something stored there, right? Let me know if I'm not looking at it right, too, because
Oh,
everybody's
yeah, you're
perspective
thinking
is...
recursively.
Yes.
Yeah.
So I think we're gonna need some sort of helper function here, right?
Yeah.
Because we can't just run binary search tree order. We're gonna need like a helper function to help us traverse the tree, because we need our base case. Yeah. So. Oops. Huh? All right. And then okay. And then I think we could just use the helper right away. Okay. So all right, so let's assume we have this 8 stored as the root node, right? We get to this 5, so that's looping through the array, and then we check to see, is this does this 8, is this 5 less than or greater than? And if it's less than, is this left taken or not? If it's already taken, then we will pass in root.left or node.left and continue to traverse this. So let's go ahead and write some pseudocode, or at least try to. So if the current node is less than the root node and left is already taken, traverse to the left, else, well, we could do this separately. Taken, traverse, else store the current node in the left. And there might be a better way to do this, just having this logic in the helper function. We could try it like this first. And then, so if the current node is less than the root node, and then we need if the current node is greater than the root node. Basically the same thing, but opposite. All right, anyone have any thoughts on this so far?
Yeah, I was thinking to build a binary tree, and indeed, just wrapping the tree node that we have and insert one by one the elements that are in the pre-order array.
Yeah, that's basically what I'm doing. Are you thinking of doing it a different way?
I think we can define an insert method. We can build a insert method, so we can pass a new tree is the tree node, and we can pass the value. So we can build this insert function as using recursion to go to the left or to the right. We can make some conditionals. We can put these conditionals that you are right in this in the comments.
Okay, yeah, that's basically what I'm doing. This helper function right here is an insert function. I just called it helper.
Okay, yeah, it's fine.
Are you in the? So you're saying take these right here and put those in the insert function instead?
Yeah, and you can also add a new argument. This can be new parameter. Sorry, this can be the new value that we are going to insert into the root. Yeah, that's fine. The loop, yeah, the loop is fine there.
Yeah. And then, so we would be passing in the root node, which is 8, right into here.
We
And
can build the root indeed to pass to the as
right,
an argument.
right here, right?
Yeah.
Yeah. Okay. And then, so, okay, cool. Is there a way to pass the actual array into the insert so it could do it all on one instead of having to like insert one by one? Or no?
What do you mean?
I didn't think in that way. Probably there is a way, but with recursion, probably.
Like if you pass the array in. We could just try to keep this simple for now.
What do you think about just doing like a for loop? Like you did? Yeah. I'm just a little bit confused on the recursion part. Do you think we should do a for loop anywhere?
Yeah,
I feel like there
we're
should be
doing
a for loop
right here.
Oh, there it is. Okay, gotcha.
Yeah, we're gonna loop through this right here. So basically, the first thing we're doing right here is we're just gonna do root equals pre-order that shift. We're just shifting off. Well, we're doing
You could do a slice.
No, shift is good. Shift takes the first element.
but
I think we already have the struct, the data structure to. Yeah, sorry, I didn't see that.
yeah. So tree node, the first argument is going to be the value. So the thing passed into it is going to be the value. So since we're shifting off the first one from the pre-order array, this is going to be 8. That's passed in as the value to the tree node. So this dot val is going to be 8. And then this dot left and this dot right is going to be undefined. Yeah. And then we're basically going to...
maybe the person who said slice is right.
Say
Because
that
if you
again?
shift it, then you lose it, right?
Yes.
There's somebody that was. So
Yeah.
we don't want to lose it, do we?
Well, we could either lose it and start at 1 here, or
You could take it as an argument.
yeah, we could start at 1 no matter what in this loop right here and just like ignore the 8. Yeah, whether we shift it off or yeah, shifting it off will rearrange the entire
If you
array.
shift it off, you lose it. Yeah.
Yeah, you could do a slice.
Yeah.
Yeah.
Pre-order 0 would be better because if we shift it off, then we're going to rearrange every element of the array, and that's just, we really don't have to do that. So, yeah.
So then after this, would you do kind of like a... So if its length is equal to 0, you want to like return it to null, right? So you don't want to really log anybody.
Let's see.
I think it would
it's
be like,
always going to be at least 1.
I think you have to do like new, right?
Yeah, that's
New
the new
tree
tree
node.
node. Oh, you're not doing new. Okay, I thought I saw new. There's my bad.
Yep.
Okay, so then maybe like if pre-order.length is...
I was just gonna do like the whole tree stuff just in the array without doing tree node at first, and then after we have the array of the actual binary tree, then use that and create a tree node.
Well, this
binary
this
version.
looks like an array, but it's not an array. This is just the way that Leetcode draws trees as
Oh,
yeah.
so it's not an array for the input. It's just the actual
No,
tree
it's
node.
an array for the input, but the output is a tree. But the way that they represent a tree in Leetcode when they're outputting always looks like an array. It's confusing.
Oh, I know what you mean.
Yeah.
Yeah, what I mean is for the output, I was just gonna. This is probably better, but I was just gonna do the array version of it first for the output, and then after you have the array version of the output, then create the tree node version of the output. That's what I was gonna do. Because it's easier to traverse an array than a tree node.
Definitely.
You know.
Yeah.
That's what I was thinking.
Can you
Yeah,
This
can
probably
you
works
explain
too.
that a little bit more? I don't really understand.
Oh, okay. Yeah, I don't do a good job explaining, but basically,
It's all good. This is what this is all about. Honestly, like that's one of the main reasons these events started is just to help people articulate solutions and just talk through these problems. So do your thing.
yeah, I might be doing things overly complicated, but the reason why I was recommending doing like just the array version of the binary tree,
Mm-hmm.
like the input is an array, right? The input is an array.
Input, I believe, is an array. Yes.
Yeah, so I was going to make the output an array as well first. And then after you have the output array, then create the tree node binary tree.
You mean using like the root left and root right?
Yeah, then after having the binary array, binary tree array, after creating that ourselves, then I was going to create the tree node last. The tree node binary tree using the tree node element.
How are you going to make an array out of the input array?
Just using the same process, like, you know, just for example, for like the very first element, zero always maps to zero. The root always maps to the root, right? So whatever for like the first step, the 8 root value would map to 8 at the index 0 of the binary tree array.
Mm-hmm.
And then we just proceed like that.
And then so the 5
would map to fortunately for us, that would also map to the 5, right?
and then the 1.
That would map to the index 1, yeah. So I was just gonna do it like that.
How would you determine that the 1 goes in the third index?
I would just use your existing logic here that you wrote, like if the current node for the insert helper function. So it just go start at the root 8, and then compare with 8, and it's less than 8, right? And then I guess that would be recursive. The insert helper function is recursive. Then we look at 5 already exists there, right? So oh, I see what you mean. So then it can't be really recursive then, because you don't know what the root is. Yeah. Yeah. I just was just gonna see if we could just create the array first.
Yeah, I'm having
But that was probably
trouble wrapping my head around that. I just don't see. I feel like that complicates and adds more to the solution than you really have to do.
Yeah, probably.
Does someone want to try to start writing or writing this out right here? I mean, we're gonna be returning the root right here anyways, right? So we're gonna be returning the root, and then so we just really have to loop through this array for each element, and we need to just traverse the array with each one, really.
Okay, so I got it. I think I got it. So in my scenario, it wouldn't be really recursive. It would just be like a while loop. And then you start at the index 8, and then you compare to 8. But you'd have to like keep track of the index. So index is 0 in the beginning, and then you compare index 0, 8 to 1. I'm just starting at the second index, 1. So we have 8 compared to 8. It's less than 8. And then, so since it's less than 8, we look at the element at the left, and that's 5. And then, since it's less than 5, then we look at what's at the position left of 5, and there's nothing there yet. So then, since there's nothing there yet, then we add the 1 there. And then, so it'd be like a while loop.
And you're still talking about
What would be
building
the
an
argument
array?
for the while? What's the parameter for the while?
I didn't. My computer shut off really quick. I didn't hear the last like 10 seconds. What parameter?
What would the condition be for the while loop?
The while would just while that input array is not it would just while it would just loop through that it would be until you have until you have a place to put that number. Just like keep comparing left and comparing the element. If it's smaller, if there's something there, then you keep going down, right? But if there's nothing there, then you add it, and then you're done. So it'd be a while until you find like a position to put it.
Okay, so you're talking about an iterative approach opposed to the recursive approach.
Yeah, that would be iterative. But I want to see you guys do the recursive way,
Yeah,
since
I want to see you do that too. So you're in the code editor, right?
Yeah.
Yeah, why don't you do that iterative solution just below this one right here? That way, at the end, we could share both solutions.
Okay, good idea.
Yeah, go ahead, try that out, and yeah, that'd be cool. Because it's definitely nice to know how to do it iteratively and recursively. So it'd be nice for anyone who's just trying to wrap their head around all of this to see both of them, if possible. That'd be cool.
Okay.
Yeah, because basically what you're saying is you're talking about doing the same exact thing. It's not like you're creating an array. You're actually creating a tree too. The only difference is instead of traversing the tree iteratively, you're gonna use something like a stack or something to push that root node onto. Then you're gonna pull is while that stack has any node on it, then you're just gonna keep traversing and adding to it, right?
Yeah, I was just thinking of like I said before, I was just thinking of creating the array first, and then based on the array, creating the tree later. But it's probably more complicated and unnecessary compared to the way that you guys are doing it.
No, it's all good. I would love to see that too. If you want to if you
Okay.
want to bust out that solution, definitely do it. I mean, we have,
Okay.
yeah, we have multiple people working on multiple solutions right now anyways. Even in the Python channel, they're still working on something or at least discussing. And yeah, so feel free to bust that one out if you want. I posted
Yeah, I'll give it to you.
I posted the function from line 39 to 46. So if you want to just take over that one right there, feel free. And then we'll continue with this recursive one right here. Does someone want to go ahead and type out the for loop here?
So these functions are the same. BST from pre-order and BST from pre-order.
Yep.
Their names are the same.
The names are the same, yeah.
Oh, okay.
So when
The variable
test them
value
out,
is the function.
Yeah.
So do you want to add like a 2 or?
I usually just comment the other one
Comment
out.
it out,
Oh, okay, gotcha.
Like
whichever one he's
we,
gonna test.
yeah.
Okay. Yeah, I'll give it a shot. 1 second. I'll be right back.
Come on, someone type out this for loop. Where you at, Kev? Omar, why are you so quiet today? Virginia,
I have
where
tried
you at?
several.
You mean the on line 17?
Today's array problem is more of a graph problem, and yesterday's graph problem is more like an array problem.
I know. What's up with that? You're right. It was. It's funny how that works out.
Yeah.
Cool. We're actually gonna start this I at 1 since we already have the 8. But nice. Okay. So I think set the node to insert, and then
Hey guys, I gotta cut out early. Thank you, Jimmy. This was awesome.
yeah, for sure. Thanks for joining. Then we will traverse. So we could actually pass the root and pass the insert node.
Node to insert. So you mean if it's smaller than the one before it, it goes left. If it's larger, it goes right?
Yes.
Yep.
Okay.
So we could go ahead and set that node to insert right here, which is just gonna be node equals tree order I. Alright. And we should be able to just do insert with the root and the node on each iteration. Then within this insert function, we're basically checking if, so check to, well, we already have most of the logic here already, right? If the current node is less than the root node, so if insert node is less than root dot val, does someone want to go ahead and type that? And then if the current node, let me make this a little more clear. If the node to insert is greater than the root node's value, and if the node to insert is less than the root dot node's value, all right. Well, we're only going to do this right here if the left is already taken. If the left is not already taken, then
If it's smaller
what's up?
and up,
How do you
No.
keep from scrolling?
There's a pin at the top right. You can click on that pin to unpin.
Oh, nice. Okay, thanks.
No, yep.
Yeah.
Well, we still have to check if All right, so if the left is already taken, traverse.
Is that the else? Else? Traverse?
Well, then what if it's greater than?
Ooh. Oh, you are right. So,
I mean, you can do if insert node is less than root val and root dot left is equal to null, then do this. Else if insert node is less than root val and root dot left is not equal to null. But I think it's cleaner and a lot easier to read if you just do if, like the way, like this right here. Here, if root dot left, the left is already taken, then we're basically doing, no, you were right. Store the current, yeah, so root dot left equals new tree node with a value of 5, right? That's else, but if root dot left, then we actually want to traverse, so we would do insert with root dot left is the root and the insert node right there, right? And then else. Okay, I think, yeah, this one looks right. How does that look? If insert node is less than root dot val, if left is already taken, so if
okay, so the first thing we're checking is, hey, is it smaller? If it's smaller, we're going down to this next if clause, control flow.
Yep.
If that spot is taken, we're going to insert, we're going to recurse. Else, we're going to make it a new one.
yeah, but instead of passing in the actual root node, we're passing in root dot left as the root node. And then we're basically doing the same thing with if the node is greater than,
We're doing it on the right.
yeah, then we're just doing it on the right, basically.
Which way are we going if they're tied?
There is no tide.
Excellent. Even better.
Yeah, all the values of pre-order are unique.
Else. So this is BBL.
Cool, cool. I'm a stickler for comments. Don't ask me why.
I think it's probably good.
All right, and then, all right, cool. So if insert node is not less than root dot val, it's going to be greater than root dot val. So in that case, if root dot right is taken, then we traverse with root dot right as the root node and the insert node being passed in, and then we're basically just doing it again. But if the right is not taken, then root dot right equals new tree node insert node. Yeah, this looks good. Does anyone have any thoughts, or does anyone see any problems with this right here?
So insert node dot val is less than a root dot val, right?
No, because insert node
Oh,
is
yeah, that's
just,
the value.
yeah, that's the
Okay.
actual value. Yep.
Okay.
We're passing that in from the base function. This is
Insert node. The insert node isn't actually a node yet. It's just it's a node to be.
Oh, that's right.
yes, exactly.
Do we
Yeah,
need
this
to
is,
return from insert?
This is interesting because very rarely do I encounter a recursive function that doesn't have a base case.
oh.
Right?
Well, it is, I guess the else the root dot left equals new true node, and the else root dot right equals new true node is the base case.
Yeah, this one right here. Yeah.
Yeah. And the one down there for root dot
True,
right.
true, true, true. All right, let's test this bad boy out. I'm just going to comment yours out quickly so we can test this. Let's see.
Looks good to me.
Tree node is not defined. Oh yeah. It's hard to go ahead, you can.
We just have to uncomment. We just have to uncomment those lines at the top.
Yeah.
Just copy.
Yeah, they just block commented it. That's why you couldn't uncomment it.
Tree node, yes.
More better now.
Let's try this one more time. All right, tree node. Let's see if this looks right. So for the first one, we're looking for, for 8 is the root. Yes.
Yeah, 8,
5 and
5, 10,
10.
1. I'm sure it'll be
1, 7.
7.
But this last one is
Yeah,
7 null.
12 has,
Okay, yep.
yeah, 7 and 12 have nulls.
7. Yep. Okay, cool. And the second one, 3 null, and oh no, they're right. That's not
Wow.
right. Oh no, that's right. The one is okay. Yep. Cool. Right. Okay, gotcha. Cool. Yeah, that should work. Let's test it out. We could go ahead and comment yours.
Yeah, my way might be overkill. Now that I think about it.
It's all good.
And you still need the,
Leetcode has it built in.
oh,
Nice.
Wow. 98, 96%.
Nice.
Thank Cool code. I try several methods. No methods work.
You were trying to solve it, Omar?
No, I try several ones, but no method work with me.
What do you mean?
Try similar solution, but I haven't figured it out.
Oh, gotcha. Did you see this one?
Yeah, it's cool code. I like it.
Okay. Thank you. Yeah, this was a fun one. Yeah, this was fun. There's probably a way to clean it up, but the thing is, I don't know if I want to clean it up because this is really good runtime.
Yeah.
I'll take this.
Yeah, it's probably as clean as it can get.
yeah, I don't think you could do much to make it cleaner.
So what I don't get with the runtime stuff is like if you submit it more than once, I guess sometimes it's faster than others. I guess is it dependent on your
They give you
Basically,
different
it's
test cases.
Oh, gotcha. Yeah.
Yeah.
They have a
Oh.
huge list of test cases, and they pick them at random.
Oh, random. Wow.
Gotcha. Yeah, I'm wondering if there is a way to yeah, there's definitely a way to clean it up. It's all good because it's already 8:13. Chilling with little man tonight. He's actually in the other room just playing video games, so cool. I'm interested in seeing other solutions though. Did you guys figure that out in Python? I'd be interested to see your solutions, and then I could share the easy problem for the night too, if anyone wants to see that one.
You said the BST?
Yes.
Let's see.
So I think GoDev got the medium one. I'm personally mentally drained from just doing easy.
Say what?
Hold on, am I cutting out? I'm probably cutting out.
Just a little bit.
So GoDev, I think they got medium and easy. I only got to easy and finished
Nice.
that. But yeah.
Yeah, it's
Awesome.
like he doesn't want to take that as an accomplishment, I swear.
Yeah, that's an accomplishment for sure. Either
Right.
one, yeah, any of these problems is an accomplishment. Even when I still finish an easy one, even if it takes me 1 minute and I know the answer right away, that's still an accomplishment.
I mean,
Yeah, definitely. You want to share your easy solution?
I guess I'll post it into the chat.
If you post it into the chat, do 3 backticks before the code, and it'll actually post as code. Yeah, nice. Oh, okay. What language is this? Python? Yeah, I could tell by these here. Def fire.
Not to get caught for plagiarism or anything, but I tried like a couple different methods, and I ultimately defaulted to what I remembered from explain his solution. Mostly because I didn't understand it. I didn't use the dictionaries are hard.
Yeah, that's exactly what I did. And you know the interesting thing about this problem right here is normally after I make a solution, if I can't think of a way to optimize it, I'll look at Leetcode's other solutions. You could actually find them ranked on time complexity and space complexity, so you could see which ones were the top ranked. And the best solutions for time and for space complexity was this same solution. And I looked at multiple of them that were all top ranked, and they were all this same O of n squared solution, which I found interesting. I thought there would be something better, but couldn't find it. Nice. And then built that this is the okay. So while pre-order temp tree node pre-order pop root
Wait,
equals
you wanted a
temp.
binary search tree, didn't you?
Who was that?
Go, Dev. John. You wanted me to show you the binary search tree before we?
Yeah. So you did
Oh, that man.
node equals while temp.
No, wait. You're. Oh yeah, I did send it. Okay,
Yeah.
cool.
Without even knowing the language, the structures, the similarity is interesting.
Oh, I
Yeah,
did. I was in the wrong chat. Oh.
it's all good. Wait,
Okay,
so
cool.
why you doing while pre-order?
Say it again. While pre-order.
Yeah.
Because I'm popping from pre-order. So
Uh,
until that thing's done, I'm not done. You know what I mean? I'm not done like going through it yet.
and popping is taking the last element from it, right?
Unless I pass a index number, correct? Which I'm popping from the front 0.
So it's like a shift in
Yeah.
JavaScript. Okay.
Right. It's just treating us like a stack like a queue or a queue like a stack. You know what I mean? Just backwards. But
Yeah.
yeah. Instead of like making anything, you know, it is what it is.
Is there a reason you popped from the front instead of just taking the value of the node and iterating through the pre-order and just targeting the I index with each iteration?
Say it again.
I'm just wondering if there's a reason that you actually chose to shrink the array with each iteration instead of just looping through it with a for loop and using I to target each element to store that. Because we were gonna go with this in the
Are you
beginning.
talking about, okay, why am I doing like a while loop with pre-order instead of like a for loop and then using like a for loop with range or something, like the length of it?
Yeah, and just
And then
using the
using like
I.
do like pre-order I and it starts at 0 and then pre-order 1 after I increment it.
Yeah, until the
All right,
length
so
of
what my thought Right. So my thought process on that was when I do it like this, I'm popping from pre-order, and because I'm creating another one to return, a route to return, I'm trying to pop and get rid of this thing. So I'm like trying to balance the memory part of it to where I'm not creating a whole nother thing. The only thing I'm creating a whole nother thing of is one pointer, my root pointer pointing at temp, so I can return my root later. So I get rid of something in pre-order, but I create something. You know what I mean?
Yeah.
So when I get done, I have no pre-order, but I have a root that has the same amount as pre-order, you know? But I didn't use any extra memory, was the goal.
Gotcha. Okay. And then while temp, so it's going to come to a point where temp doesn't have a value either?
Yeah, because now I'm going to traverse from the top of my root. I want to know if, all right, is this number, this node that I just popped from pre-order, because there, it's the first thing. When I take that number, is it less than or greater than my root? Because I'm going to start at my root, and then I'm going to go down whatever path it is. If it's not less than, then it's else. It's greater than. So I'll go, all right, if it's not temp right, and that just means if temp right is none, So that means that I can't go any further. I need to assign it. So my temp right is now node, and I'll break this while temp. You know what I mean?
Yeah. Nice.
But if
I like it.
Yep.
Yeah, it's very similar to ours. I don't know if you saw this one. This one was ours too. You went with the iterative approach too, which I found interesting. Who was it?
I've been working.
There's someone in here.
I'm trying to work on the iterative because, man, recursive can sometimes you can fall into I know it's a couple lines of this and that and it's done, which is cool. But I want to understand how it fully is creating a stack on the recursive stack on the back end. Maybe I want to make the stack and do it,
Yes, yeah. I think both are really important to know because I've heard of people who interviewed at Google or bigger places, and they would say traverse a binary tree recursively, or they would just say traverse a binary tree, and if you chose recursive, they would say, okay, now do it iteratively. But if you did it iteratively, they would say, okay, now do it recursively. So it's like,
right.
It can't hurt to know both of them for sure. Yeah, this was our solution. We went with the recursive option. We set the root node to tree node pre-order 0. So we just took that 8 and we stored that 8 as the value of our first tree node. And then we looped through the remaining of the pre-order. So we started at 1 since we already got the 0. And we went from 1 to the length of the pre-order array, incrementing I at each one. And then every time we started this loop over, we just took pre-order I, stored it as the node, and then we passed the root and we passed the node into the insert function. And then our insert function just takes a root. It takes an insert node. So if the insert node is less than the value of the root that was passed in, then we make 2 more checks. If a left node or if a root.left exists, then we continue to traverse and we run this insert function with root.left passed in instead. but we're still passing in this insert node because we want this to come with us for the whole journey until we actually find a place to insert it. And then if there was no root.left, we just set root.left to a new tree node with the insert node. And then we did the same thing for the left. I mean the right, basically.
So, isn't that a little bit of both? Like a little bit of iteratively, recursively calling something?
Yeah, you could say that. Yeah,
You know what I mean?
we're using iteration to traverse the pre-order array, but we're using recursion to insert nodes. So yeah,
Man,
there's two
look at
mechanics to it.
that. That's cool. Okay.
Yeah, this was a fun one. Does anyone else have a solution they wanted to share or have any questions about anything tonight?
Did you already do the count pairs one? The easy one? Did y'all do that? I see Andy, he turned his in. Were y'all able to?
Let me see if count equal divisible pairs, right?
Yeah.
Yeah, so this was my initial solution right here. Just a for loop and a for loop kind of thing. Same thing that you guys did, or same thing that Andy did. But then, like I said, I checked Leetcode. I checked the most efficient time and the most efficient memory, and they were both the same, just slightly verified. Or slightly varied. Yeah. What did yours look like? Did you do it?
Yeah.
You posted it?
No, the other one, from a hammer, I'm gonna switch it over right here. I got two of them. I got three, but we're gonna do the last one in a second. But those are the two that, like, the top one is typed out from a list comprehension, because me and Andy were going over that. We were just kind of like breaking it down. You know what I mean? Yeah, I had all that and into a one-liner kind of thing.
Yeah.
And so I broke it out just like yours. You know what I mean? That's pretty much. And then the other one just kind of tackles it a little bit different. And
can I just ask you, this range right here, you're passing in n range of n.
Yeah, so you see where n is? You see how it's there twice, but like for j in range of I plus 1 of n,
yeah.
every time I iterates up, the that n, if I had length of n, it's going to have to call it. So then for for each j in that range right there, it won't have to, but every time it has to call, like every time I increments, then this 4j is going to be new. So then if I had length of nums, it would have to call it. Yeah. You see
Okay.
the I plus 1? So what I did is I do it up there, so Python only has to call it once, or any program, I guess, I don't know. But then it only has to call it once, and now down here, n is a number that's not changing. It doesn't have to call anything, it's part of its memory. So it's not calling a function, and it's not running length on the list, which the list could be very big. And every time it incremented on I, we'd have to run that. So now we're not having to do that.
Yeah.
So that's a function we're not running on top of the other stuff we're doing. So that's why I did that. And the I plus 1 is because you never want to check anything behind you.
Yes.
So.
Yeah, I like that. And then this one here. This is the same one? Count pairs, yeah.
Yeah, that's the count pairs.
Huh.
That one was one when I was trying to use some maps and stuff to make it to where it was like not O of n squared or O of n, n squared. if we got to do two full nested loops.
Did this one work?
Yeah. Oh yeah.
Huh.
That one was 100 milliseconds faster than the other one.
Yeah, I could imagine.
Yeah, that one was the fastest one I had. Where is it at? There we go. Submissions. Yeah. So the other one was like 249, and then that one was 166 milliseconds. So
That's interesting. I feel like this one would be. Well, for this
So-
one, you have a triple nested for loop.
Well, in a way. So the thing about that is I'd have to print it out, and show you what the values are for one, and see how it says for I in val, for J in val.
Yeah.
I'd have to show you what the val is for one, and then all that is a number, by the way. So then it comes down here, or it's a list. I'm sorry, it's a list. So then it pulls up a list of the amount, of the indexes that number showed up at. The key being that number. So you're not running through the whole list on any of them.
Yeah. You're only running through the values that are actually in the index map, and you're only running through the indexes.
So like I get to one and it only has one thing in it. So that triple nested for loop only ran once. Or three times is the most on the example one. But it's I was like, oh, that's why. Okay, that's pretty cool. That's pretty cool. So then I don't know. I was telling Andy I pretty much thought this was an O of M, but I now that I look at it more, I think I misled the gentleman. And I'm sorry, Andy, if you're still here and listening, bud. But let me show.
You don't have to worry, because I didn't understand it anyway.
Oh, let me do this real quick, and then we can evaluate it. Somebody can maybe help me, because this, at least
Well, for the values in index map, it's gonna be n divided by 2 maximum, right?
And where is it?
For the values in index map dot vals.
Yeah, that's the only ones that have met greater than 2. Correct. The line above it is a dictionary comprehension. It's just it's like a for loop inside of it, and the last part being the if condition. So basically,
values in index map are only values that have showed up more than once in the array that was passed, or the nums array that was passed into the function. So
because in the future we're going to have that actually simplified things. That made me not have to check the this equals this feature.
Yeah. So I could see it being okay.
So that, and none of them are n of n squared, but it's something. It's n plus something. I guess we'll just say m being the amount of possible indexes a number can show up, which could be n. I guess every number could be the same, possibly.
Yeah, but even if every number was the same, values in index map would be n divided by 2, right?
Oh yeah. Well, yeah, it would only have the map would only have one thing, and it would be a list, and then I'd be running through that list.
So there would only be one value.
In the index map, but
in the map, yeah.
Yeah.
But there would be a list inside of it.
Oh,
Be running
of all of the indexes, correct.
Yeah, okay.
Yep.
Yeah, gotcha.
So worst case scenario, it still is. Yep, that is still running through, because that's if every number was the same, right?
Yeah.
But yeah. That's the case.
Nice.
So that one didn't work, but the next one was that was the one that I needed some clarification on, because the way I do the 2 pointers, they eventually meet up in the middle, kind of thing, or surpass each other.
Huh, okay. I was working on a pointer problem today, and I was like, I thought I had it like 3 times, and I just kept so many edge cases. I was getting so frustrated. Alright, so I equals 0, j equals length numbers minus 1, n equals 0, while I is less than j. Okay.
Yeah, n was the last second thing. I was like, oh, I'll use n as a return. Yeah. So basically, if it's, in order to move the pointer, whether it's the left one, I, or the right one, J, is dependent on that if condition. If not, then you decrement J and bring it in closer to I, But Leetcode being weird, that one was not faster than the other one. But I guess none of theirs had the same number, maybe. I don't know.
Yeah, no, because if j equals I plus 1, you're resetting j at the length of the array, so it's constantly jumping back to equal the length, right?
Right. Maybe I can add like a base case if condition in there or something like if length of values is same as length of whatever the main thing, then here's your number.
I
But
like
yeah,
it. I like it.
this one made a little more sense. It was just a little while loop.
I like it. Nice. I like how you come up with multiple solutions too. I do the same thing. I try to come up with at least like 2 or 3 right now.
Yeah.
I can't wait till I can start coming up with 2 or 3 different solutions on the hard problems. That's like the goal. Then I'll feel good, you know?
Oh, dude.
Right?
I mean,
I'm lucky if I can come up with 1 on the hard one.
man's going crazy over here, just spitting hot fire. Said I'll be doing. Gosh,
That's
crazy.
like the goal, right? Like I
Right,
remember
right.
when I first started the easy problems, and it was like I was just so happy to even find one solution, you know? And
Yeah.
now it's at the point where I'm thinking of multiple different solutions that I'm implementing the best one, and then I'm still writing out a couple different ones just to see if they work, kind of thing. And with the medium problems, I'm starting to be able to think of more than one solution. So I'm almost, I give it like 30 days. I bet you I'm going to be thinking of multiple solutions with the mediums. But man, when I get there with the hards, I'm going to feel so good. But it never ends. There's just going to be another goal after that, you know?
Yeah.
Yeah.
Yeah, never ends. If Kevin's right about anything, then eventually we'll just be telling these computers to solve our problems and we won't even have to write code, right? They'll just do it for us.
That'd be great. I mean, maybe it won't, but maybe it would be great.
Anytime I read an article about AI now, I think of you, Kev.
Sorry.
I think of that Tasmanian devil, like Kevin warned us. Nah. All right, well, looks like it's about 8:35 right now. I'm gonna go hang with Lil Man. So if no one else has anything else to say, then
Hey, y'all have a good night.
Yeah, you do.
awesome. Thank you.
Yeah.
You too. Yeah, thanks everyone for joining.
Oh, thanks for sending that in, Pandaroba.
Yeah, I'm trying to figure out, like, I don't fully understand the concept of binary trees. So I was kind of trying to understand the logic of that.
Hold
I
on.
was looking at it.
Panda, can you post that code one more time, but now, right before the var, put 3 backticks.
Okay. So the whole time I was like reading articles on binary trees.
Yeah, that's good.
Oh, backticks. Sorry about
Yeah,
that.
backticks right before the var.
Okay. Do I need a space between?
I don't think so. No, I didn't need it.
When I try to send it, it just keeps going down in space.
Oh, that's strange.
Okay.
Let me see if it works here. What language is this? JavaScript?
JavaScript.
You have to put 3 at the end too.
Oh, okay.
Yeah, if you put 3 in the beginning and 3 at the end,
Okay.
and
that.
you could write,
I think I did it.
if you look at my screen, if you do backtick, 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 and then write JavaScript,
Oh, okay.
and then backtick, backtick, backtick at the end, it comes out looking like this.
Okay.
So it actually looks like clean code that people could read. Just throwing it out there because I saw that the code you posted.